to me and asked me for help. When I showed them, they all said the same thing. Oh, okay, got it. I guess what my message there is that don't always assume that just because it looks complicated, it is complicated. These are not that complicated, the table. Always give it a shot. Any questions? All right. Okay, I don't want you playing musical chairs every day, Ben. Okay. That was a good seat for you over there, too. So Monday, over there. All right, here we go. Number one is both area and perimeter. The area is 1,050 centimeters squared, and the perimeter is 130 centimeters. Number two, the area is 44 meters squared. The perimeter is 32 meters. Number three, the area is 2,665 square kilometers. The perimeter is 212 kilometers. Number four, the area is 6.72 square units. A couple people said, hey, what? There's no units there. I said, use the word units. So you'd put square units or units squared. No, you don't make up your own units. You use the word units or the units they give you. The perimeter is 13.8 units. I'm going to look at all the tables. So I will grade that portion. All right, here we go. Grab all the homework, quickly pass out.
I'm not good.
Yes, you are. Quickly.
Gavin, you want to switch?
No. You're a good passer outer. Everyone else, not time to talk, time to look at the calendar. As we look at the calendar, guys, as we look at the calendar, we got a solid week next week where all we have are classes, no quizzes or tests. It's a lot of stuff. Every day you're going to get, today you're going to get 2 new formulas. Some of you have never seen these. Some of you may have seen one of them, but some of you have not seen either one of the 2 new formulas. Okay. Next week, it's the same thing. New formulas every day. Okay. It's a lot of stuff. We will do a review and then a quiz. All right. Here is your homework. Copy it down. Notice it's 2 parts. Class exercises. I rarely use class exercises, but I'm using it this time. You're going to do class exercises 1 through 6 and written exercises 1 through 10. So for those of you that always make a mistake, you do the class exercise instead of written, well, today I'm asking you to do both the class and the written. Class exercises 1 through 6, written exercises 1 through 10, and it's an all, so it's evens and odds. Malachi, you got it written down? Where is Elijah? Catch. Coming at you.
Oh, you're done?
Good. Just remember, if you don't do your homework, I never forget to put the 0 in the grade book. Never.
You did
right?
one time for me.
I never forget. It prompts me. That's why I don't forget. It's not because I'm that squared away. Do your homework. That's your job. That's your job right now in school is to do your homework. You're not going to remember any of this stuff. You don't get practice at it. Yes. Get your homework?
No, I need to get.
Go ahead. I was
Laughing,
I was
right?
hoping there would have been more.
Oh, by the way, you see what it said at the end? It said Ace King film.
All right, here we go. Well, actually, one of them took poison, one of them stabbed themselves, right?
Yes.
Right.
Or have you gotten that part? Did I just ruin it?
We already know.
Okay.
And plus, but in the trailer, she didn't see her hand.
That's good.
Maybe
We're not
because
allowed.
she took the poison, or did he take the poison?
I took the poison.
He Gavin took the poison, Jasmine stabbed himself.
That's crazy. All right.
Young lovers.
All right, here we go.
Oh, yeah.
I'm going to warn you. For some of you, you haven't seen these formulas before. One of them is challenging. One's not too bad. And then I'm going to give you the same warnings that I gave you every single time for this chapter, which is it's done with a calculator for this chapter only, meaning that, no, it's not that I'm giving you easy stuff, use a calculator. It's just that I want to be able to do many of these quickly, right? I'm teaching you how to calculate area and later volume and surface area. Using a calculator just allows us to do many of these problems quickly, right? I'm trying to show you, take the shape, identify the shape, identify the correct formula, plug in the correct numbers, get to an answer. All these can be done easily by hand as well, but we can do fewer of them. And the practice is, you know, plugging the right numbers into the right formulas that apply to the right shapes. Resource cards, some of you started making it yesterday. That's a good idea. There's lots of formulas, lots of formulas. New formulas every day. You get 2 of them today. For all problems, 4 steps. Every one that you did, was it Bo said, hey, this is getting pretty lame. I put abbreviations. Absolutely, that's fine. But for all problems, you identify the shape. You write the formula with no numbers in it. That tells me you know what the shape is and you've chosen the right formula. You plug in the correct numbers. You look at the right dimensions. You plug in whatever it is the formula asks you for, and then you do the calculations. You write your answer or units. You do those 4 things, right? 3 of them you will write down. Identifying the shape you don't write down, but 3 of them you will physically have on your paper every problem. Okay. So as I grab someone's homework at random, the very top one, Josh, every one is wrong. It could be the right answers, but I'm saying you got to follow these, at least these 3. You got to write the formula. Right? If I grab the second one, Matt, you are wrong. Riley, you are correct. Felicity, you are correct. Nick, you are not correct. That's 3. Caden, you are incorrect. Nevaeh, you are correct. I'm trying to pick the nicest one out of all of them. Abby might be the nicest one. Jameson, incorrect. Jameson, that's your second one, sorry. This one looks good. Pierce looks good. Not as good as Abby, so. Oh, where's yours? You had perfect. Oh, Bo's was the one that I saw. Bo's and Abby's are the perfect one. If I called your name out that was badly, this is what it needs to look like. They wrote the formulas. They plugged in the numbers. They did the math. They wrote the formula. They plugged in the numbers. They did. I didn't call you. Somebody over here.
But can I just see?
Sure. It's just a blank formula. Then they plug in the numbers and then they do the math. That's what it should be. All right. Okay. I mean, woe unto you if you don't do that. I will mark yours wrong, even if you have the right. Oh, that's being a jerk. I agreed. I am being a jerk on this, right? It's for 2 reasons. One, it's the right way to do math. You don't just put random numbers on a paper. You're writing on a paper for a reason. You need to be able to read it. Come back to it. Give it to someone else. They need to be able to read it. The second thing is, as a teacher, it allows me to give you some partial credit if you do something silly. You plug the wrong number in, at least I know you knew it was a cylinder and you plugged in the right numbers, just the wrong places. At least I can give you a point or 2 for trying. You just have an answer and it's wrong. The whole thing's wrong. All right, new shape, box 1A. There's 3 boxes there. Box 1A, write this down. You are a triangle. We've already written this down previous chapter. You are a triangle if you're a polygon. Or polygons are made of shapes made up of segments joined at their endpoints. You're made up of segments joined at their endpoints and you have 3 sides. You are called a triangle. There's a triangle. Draw 1 triangle, box 1A. Doesn't matter the type. Closed plane figure consisting of segments joined at their endpoints.
It's so perfect.
All right, that's because PowerPoint made it. I didn't make it. All right, in box 1A. Yes, it looks like the bottom is called the
Base.
It's not. It's one of the sides, just like it was for parallelogram. One of the sides is called the base. Generally speaking, we like the bottom to be the base, not because we have to, just because we're creatures of habit. Okay, one of the sides will be the base. The perpendicular distance between the base, there is no opposite side, right? But there's an opposite vertex, okay? The perpendicular distance between the base and the opposite vertex is called the
Height.
It is called the height. Write that down. Yes, generally speaking, we make the bottom be the base. Doesn't have to be, right? Base.
Yes, it kind of to make us happy. It kind of does.
The next box, I'm going to force you to do it all 3 ways.
Do we have to rewrite the word height and base
the definitions since we already have it in our last.
Yeah, but this one's different. Remember, for a parallelogram, the height was the distance between the base and the opposite side. There's no side here, there's a vertex here. Okay. Some books, I always throw this out, some books call the height the altitude. Right? Our book doesn't. But in case you ever encounter that word, altitude is just another name for height.
Right in the lap.
You okay?
Right up there.
All right, all that in box 1A. Right small. Moving on. Box 1B. Because the base could be any one of the three sides, let us consider that one. We're just drawing shapes in box 1B. Draw this one. The base is now where?
On the bottom.
On the bottom. For the middle one, I don't see anyone's pencils moving. 1B, draw the shapes. You're going to draw 3 of these, leave space. No words, just 3 of them, other than base and height, sorry. For the middle one, I want you to make the base either the left side or the right side, either one. Doesn't make a difference. Draw the height. For the middle one, I want you to make the base either the left side or the right side. It doesn't make a difference. Draw the height. Remember, the height does not go to a side. The height goes to the vertex. That's the corner of one of the corners of the triangle. Notice this height looks very different from that one. It's actually not the same measurement.
What?
This height is smaller than this height. Lastly, there's one type of triangle that you will encounter where there will not be a dotted line marked height. But there will be a square. What kind of triangle would that be?
Right triangle.
That's your third one. That means the height is one of the sides of the triangle. These are 3 of the 4 that you will encounter. One gets its own box because it's weird.
How do we know which one's the base? Because it could be either 2.
Correct. Either one's fine.
And then for the height.
So what Ace was saying, well, couldn't the base be this side, but therefore then that would be therefore the height. So that's true. Not true on these 2, right? All right, we okay with those 3 pictures? If I walk to your paper, you have those 3 pictures drawn with the word bases and the heights.
Wait,
To the right,
Say again?
to the right triangle, do you still get it to the vertex, or why do you?
You do, because look, it's going absolutely to the vertex. Or if you choose this to be the base, then it's still the height goes to the vertex. Okay, one triangle gets its own box, 1C. It's weird. All right. Draw this one, box 1C.
It's an obtuse triangle.
It is a scaling obtuse triangle.
It's a triangle in the first box.
Here's the issue. If I make the bottom the base, what happens when I try to draw the height?
it's too
It goes in the wrong direction.
Oh no.
So we will do the same thing like we did with that one parallelogram. What did we do yesterday?
Move it to the left.
We extend the base over. You'll see a second dotted line, and we literally just move the height over to right there. The dotted line right here coming from the base is not part of the triangle. It's just saying, hey, we extended the line of the base. You will see this tonight or over the weekend.
That's evil.
Scaling obtuse. It's weird. We good? Occasionally, there will be a number right here. That number is not the base. That is literally the distance from here to here, which we can use later on in high school. We just won't use it this year. It's not part of the perimeter. It's not part of the measurement for area. It's just showing you, well, there is a distance there. We are concerned with how long is the base and how long is the height. All right, box 2 very quickly, 30 seconds. For each triangle, put what is the base units wise and what is the height. It'll take you 30 seconds. Go. Anybody lost in what I want you to do? I put all the numbers up there because it can be confusing at times.
You still don't know the
I
Fridays.
still don't know Fridays.
Don't worry, Mr. Sharkey. Neither do we.
No one knows.
Why do we even have
That's
school
even
on
All right.
Fridays?
Do the work. Why what?
Why do we even have school on Fridays?
Why do we have school on Fridays?
We're gonna make it an hour
We would-
earlier.
You want to go to school during the summer?
Why do we even have school?
Hey.
I'd much rather go to school in the summer.
What do you want to do with your life?
Nothing.
Well, then you don't need school.
Mr.
Well, but I
Sharkey.
have
But it's illegal to not go to school.
Well, not if you do nothing. What, do you think they can force you?
Yes.
No, they can't.
Yes, they can. Your parents can go to jail.
Yeah, your parents can. Not you.
Oh.
Mr.
Why don't I want my parents to
Mr.
go to jail?
Well, that's why you're going to school. If you can't figure out why you're at school and you have to ask silly questions like, what do I got to go to school? And you can't think this through. How old are you?
I don't know.
By the way, we're having a conversation. It's not a. How old are you? 12?
I think so.
I know it seems like a long time for you, and it probably is for you, but 6 years from now, you're going to be an adult. If you don't have a job or you're not doing something with your life, the world doesn't really care at that point. It will let you, I don't know, take it to the logical conclusion. The world doesn't care when you're 18. They care right now. Like by law, legally, we have to give you an education. It's not that we don't want to. We want to. We want to help you become a productive member of society. If you can't wrap your head around, you got to do something with your life after you turn 18, then you better wake up to that inevitability.
Who would want to? Society sucks.
All right, no, we're not going to get off the topic. Here we go.
I had a question on the
First triangle. Pierce, what's the base and the height?
Base is 2 inches, the height is 3 inches.
Anyone questions on that? Hey, why did I put a 4 here? What?
Maybe to do
Perimeter, right? But not for.
To trick us. To try
All
to
right,
trick us.
Gavin, second one, base and height. And I'll get your question.
The base is 15 and the height is 10.
Yeah, the base is not always the bottom. In this case, the little square touches the base and the height. Base is 15, the height is 10.
Oh, so it's whatever the square.
Last one. What do you got, Jasmine? Base and height. See what I mean? How that can be confusing?
That's 4 and 8.
The base is just right here. The base is 4 and the height is 8. Did anybody else get tricked by that one? Scaling obtuse ones will mess with you. All right, Pierce, you got a question? Okay, cool. All right, remember from the last lesson that if you have a parallelogram, what's the formula for area?
Base times height.
Okay, base times height. Cool. All right, watch what I do. Think about this. Hey, parallelogram. It says triangle. There's no triangle here.
There is-
Or is there?
Yes,
Well, how can I make a triangle?
2 of them.
If I cut this parallelogram, which the formula is base times height, if I cut this parallelogram in half, how much of the parallelogram is right here? How much is here? I did backwards. How much is here? Half, right? Therefore, if I erase one of these halves of the parallelogram, if I erase one, move it, get away, I don't want you anymore. I am left with just a,
Triangle.
but then the formula can't be base times height because I got rid of half of it. So how much of this formula is left?
Divide. Oh,
How much of the formula is left?
half of it.
Half of it. That is why the formula for an area of a triangle is half of a parallelogram.
So would that be base
Oh,
times
we'll
height?
go here in a second, right? So that is the formula that is in the book in box number 3. Write this down. Box number 3. Area of a triangle, 1/2 base times height. I don't know of any math book that doesn't say that. I don't know of any time that you take a standardized test and they give you a formula sheet that it doesn't say 1/2 base times height. What Pierce wants to urgently say is this. There is a calculator more friendly, and that is,
It's base times height divided by 2.
so for many of us, we would rather write that formula. I'm okay with that. That is your calculator friendly calculation, right? That is your calculator friendly, right? Calculator friendly calculation. Why is it more friendly? How many keystrokes does it take for you to type in a half?
3.
How many?
3.
1 divided by 2, right? That's 3 keystrokes.
What would happen if
Divided by 2 is 2, so it saves you 1 keystroke.
What would happen if you divided 1 by 2?
Somebody, you get 0.5, which is a half.
Nothing special.
All right. Are we good on the formula? It's not challenging. You find the base and the height. Once again, on a triangle, to find the base and the height, our eyeball should go to the little tiny square. The little tiny square touches the base and it touches the height, even if there's other numbers around it. If your eyeball goes to the square, you can find both the base and the height. What's the base and the height of this triangle?
8 and 7.
Those are the numbers that we throw it in. Now, if I did this by hand without a calculator, I'd have to do 8 times 7, 56 divided by 2, 28. I could also take half of 8. Half of 8 is 4. 4 times 7 is 28. Any one of those will work. If I use this with a calculator and I use the calculator friendly one, base times height divided by 2, well, the base and the height is still 8 and 7. So I do 8 times 7 divided by 2. 8 times 7 divided by 2. 5 keystrokes. Well, 6 if you count the equal sign. Who's lost? Remember, I have to put units. Since we're calculating area, area is always in square units. Literally, how many squares does it take to fill that shape? We're not filling this sucker full of squares because it's a triangle. You'd have to put half squares and third squares and fifths of squares. It would be a messy proposition to literally fill it full of squares. The cool thing is that the only one we ever actually fill full of squares is the rectangle, and all the other formulas come from the rectangle. We got the parallelogram from the rectangle. We got the triangle from the parallelogram, which came from the rectangle. All of that boils down to is you can fill it full of squares. All right. Once again, the formula says 1/2 base times height. Your eyeball goes to the square. The square touches the base. It touches the height. Doing it by hand, what's half of 10 times 8 is 80. What's half of 80? Okay. You can also say half of 10 is 5. 5 times 8 is 40. You can say half of 8 is 4. 4 times 10 is 40. Lots of ways. This one isn't too bad to do by hand. With a calculator, base times height divided by 2. 10 times 8 divided by 2. Who's lost on triangles? Easy or hard? How many formulas do we have now? 5. Yesterday we had 4. Here's your 5th one.
We're gonna have a 6th.
We're going to have a 6 by the end of the day.
No.
All right. What's different on this one?
It's just on
Where's the base?
on the side.
What is the base?
9
It is 9, not 10. It is 9. I will have students, Keegan. I will have students that because they're so used to the base being the bottom, it doesn't matter. They will always put the bottom number as the base. The square touches 9 and 8, not 10. So we throw those values in. If you're doing it by hand, half of 8 is 4. 4 times 9 is 36. If you're doing it with a calculator, 9 times 8 divided by 2. Have I lost anyone? Okay. Wait a minute. What kind of triangle is that?
That's a right triangle.
It's a right triangle, but it still has a square. The square touches the base and it touches the height. 10 and 7 are your base and your height. Half of 10 is 5. 5 times 7 is 35.
So really the side serves as another side and the height.
Correct. Doing it with a calculator, base times height, 10 times 7 is 70 divided by 2. Plug it into your calculator. We okay?
Yes.
All right, take box number 4. Yes, I keep using the same triangles over and over again.
That's okay.
Right? Area of all of these should take you less than a minute. Because in box number 2, what did you write down? You already wrote down the base and the height in box 2. So you already have the 2 numbers you need to multiply and divide by 2. If you wrote those down. Got it all done, Keegan? Sweet. Where's your calculator? Okay. What was the saying about the calculator? What did I say about a calculator? I said that on the test, friendly or easy numbers here?
Easy.
These are easy numbers. I make them so that if someone forgets their calculator that day, they can do it. On the test, it's going to be 157 and this is going to be 26. Okay. If you don't bring in your calculator, you will have problems. Right? I designed the test with in mind that everyone has a calculator. Therefore, I use unfriendly numbers. No, it's not mean. It's real life. Rarely do you have a triangle where it's always friendly numbers. All right, here we go. Malachi, first one. The area is 3 what? 3 square inches. Very good. All right. Here we got the middle one. Tell me what to multiply. That's 150, and then I have to, by the formula, we could also take half of the product of the two numbers, either one. You can take half of 15, then multiply by 10, half of 10, multiply by 15, or multiply 15 times 10 and then divide by 2. 15 times 10 is 150, half of that is 75. 75 square centimeters. Last one, what do you got? Anybody? No.
I got 16 square meters.
16? 6 times 8 is 48. Half of 48 is 24.
That's 4 times 8.
Why isn't it 6 times 8? 6 is not the base. The base is 4.
That's just how much you extended.
Right. That's just how much you extended it. Right. All right. Triangles, I generally don't have anyone have issues with triangles either. I don't have rectangles, parallelograms, triangles, and all the other shapes from now on. Oh yeah, kids, these are the ones you miss. So for those of you like Ace who hasn't paid any attention yet, right now you better start paying attention. First one that we will do, write this down, box 5A. Trapezoid. That means it has 4 sides. It's a quadrilateral with 1 set of parallel sides. 1 set of parallel sides. Jasmine, right.
Every shape surpasses the trapezoid.
1 set of sides are parallel. The other set is not. Great. That's box 5A, 1 trapezoid.
Is all we have to write down?
In box 5A, yes. All right.
What's happening down there?
Hey, hush, pay attention. Box 5B. All right, we're going to label the parts of a trapezoid. So in 5B, draw a trapezoid. We're going to label the parts. Hey, we're going to label the parts.
I think it's pizza day.
Okay. Label the parts.
I think there's an
Hey, it needs to stop right now. The 2 sides that are parallel will have names. Which sides are parallel on this one?
Top and bottom.
Top and bottom. Does it have to always be the top and bottom?
No.
I could take this thing and rotate it 90 degrees left or right. It would be left and right that were parallel.
Yes.
The 2 sides that are parallel, one of them, it doesn't have to be the bottom, pencils in your hand. One of them will be called base 1. The other one will be called base 2. They're clearly not the same distance. So we can't say base or bases. We have to have label one base 1, the other one base 2. Okay? The distance between the 2 bases, take a guess. It will be called the height. The distance, and it will be perpendicular. The distance between the 2 bases will be called the height. So we've been using these words, base and height, in almost every shape except for the rectangle.
Okay, so now wait.
This was all in box 5B.
Oh. I just found box A.
Okay, well then great. Then you got an extra box that's empty. All right, make sure you put height. Height is the distance between the 2 bases.
I got it.
If this is shifted left and right, then the height goes left and right.
It's just always the 2 sides.
It's always the 2 sides that are parallel. Distance between them. Okay, we good? All right, box 5C, draw all of these. These, just like the triangles, these are how it will appear. Either the parallel sides are top and bottom, or they're left and right, or you have what's called a right trapezoid, where one of the angles is a right angle. Just like for the right triangle, then the height ends up being that side that has the right angle.
Oh.
Notice 2 of them have a dotted line, easy to find the height. One of them does not, but it does have a square. So the height on the right trapezoid will still be the distance between the two bases. It just won't be dotted. So use the side that has the right angle. Yes.
You can also flip it around and there's another.
You can. There ends up being this. If this one's right, then that one's right as well too.
Does it make a difference?
It doesn't. Right. But remember, I don't have to draw this one as right though. I could easily. Oh wait, that wouldn't work, would it? Because then it'll no longer be parallel. So it will always have that. Right? That doesn't work. So remember, you gotta have two sides that are parallel. So if that's a right angle, then that one will be as well. All right, here we go. Boom, there's a weird formula. I want you to write it down first.
Yay, Jim does.
This is the formula. I'll explain where it comes from here in a second. This is the formula for area of a trapezoid that is in your book. It says area is equal to 1/2 times the height. We had subnotation the other day. That means base of side
1.
and base of side 2 that you label base 1, base 2. Yes. Yes. Box 6. This is the uncalculator friendly one. Oh, sorry. I'll show you the calculator friendly one here in a second. Now I have GEMDAS there because you got a lot of stuff going on here. You have division, you have multiplication, and you have addition right here. Okay. You got to do parentheses first. Okay. If you're doing it by hand. Once again, if you have the dollar calculator in mind, if you have a dollar calculator, you got to do it by GEMDAS. If you have the scientific one that has parentheses, you type it in exactly the way it appears.
What is H going to be? Oh, height. Okay.
All right. So let me briefly show you where this comes from. Oh, actually, I don't have time. I will show you this on Monday where it comes from. All right. I will show you this where it comes from the fact that there's two triangles.
No.
All right. So this is what's in the book. The calculator friendly one looks like this. You do the parentheses first. Base 1 plus base 2, close your parentheses. You multiply by the height, you divide by 2. This is the calculator friendly one right here. I would suggest that you write it down.
Aren't they both calculators?
They are, but one is less keystrokes. If you put that half first, it takes 3 keystrokes to type in either 0.5 or 1 divided by 2. Divided by 2 is 2 keystrokes.
Actually, you only need 2 for the 0.5. You don't need 0.
But you do have to hit a multiplication symbol, so it's actually there. Hey, Jaden, what are you doing? Put all your stuff open. We're not done. All right. We're going to do 3 of these, even if the bell rings. You ready? All right. We're going to do 3 of these. All right. Let me get to the first one that you have. First one you have is
This one.
box number 7. Let's do box number 7. You ready? All right. To do an area of a trapezoid, we need the 2 bases. Your eyeball should always go to the square. The square touches the height, and it touches at least one of the bases. Remember, the definition is the height is the distance between the 2 bases. So the 2 bases here are, and the height is, write this down. Step 1, you write the formula, either calculator friendly or the other one. So you write the numbers in. The 2 bases were 6 and 4, 4 and 6, and the height is 5. 6 plus 4?
It's 10 times 5.
10 times 5 is,
50.
okay. Or you could say half of 10 is, 5 times 5 is, I'm giving you nice friendly numbers in class. Okay. Okay. So the other version over here, calculator friendly, it's still the 2 bases, which are 6 and 4. Half of 10 is 5. Me, I'm always going to make my life a little bit easier. I'm not going to do the multiplication the way that they say I must do it. I'll do it in the order that I choose. All right, who's lost on how I got 25 square inches?
I finished 3 of them.
I said we're going to do 3. There's 1. Let's do 2 more. Which one do we want to do?
The first one in number 8.
First one. What's the base? What were the two bases of the first
4
one?
and 8.
4 and 8. So the formula says take the two bases, add them together. So let's see, calculator friendly. 4 plus 8.
I unfortunately.
What's the height?
6.
And we got to divide that whole thing by 2. Jaden, pay attention. Write this down. We could actually do this in our head. What's 4 plus 8? 12. What's 6
72.
divided by 3? Or 2, sorry. 6 divided by 2 is 3, so it's 3 times 12, which is 36. And the units are centimeters. Okay. What's the other one we're going to do?
Next one. No, the last
The last one. All right. What's the two bases there?
7 and 10.
So it's 7 plus 10 times the height, which is all divided by 2. Okay. 6 divided by 2.
3.
7 plus 10.
17.
Oh, 17 times 3.
I wonder.
Carry 2.
Should be
51.
102. Yep.
But then we divide by 2. All right. So here is nice and pretty all of the answers. Have a good 3-day week and see you on Tuesday.
This is easy.
It is. People forget this formula all the time.
This formula.
Hey, what do you like to do in your spare time?
I don't know.
You do.
Video.
Video games.
And sometimes
Would you like to be in that industry that makes video games? Yeah. Designs video games, sells video games? There are hundreds of thousands of jobs. Hey, you know the worst thing about playing a video game? It's the very end. What happens at the very end of a video game? You get, hey, can you take this serious for a second? What happens at the end of a video game? You finish the whole game.
you don't play every day.
No, what happens on the game when it's done? Like, how do you know the game is over?
It says game over.
It doesn't say game over. What is it? What happens?
The credits.
The credits roll. How long do the credits roll?
I don't know.
Have you ever watched them?
Like
You want to
10
know
minutes.
why? Kaden, why?
Because they have like hundreds of people working on it.
No. It's thousands.
Yeah.
Hey, can you take this serious for a second?
Yeah. That's what like
There are thousands of people. I would even wager it's probably more than, it might mean the tens of thousands that make a single video game. Those are great jobs. You could have one of those, but you got to start doing something. I'm not saying you got to make video games, but you got to figure out something to do in life. That's the motivation for doing well in school. Okay? Because when you turn 18, the world doesn't care.
those are like AAA games.
All right.
Walking at the right time.
It's one of those, why am I in school? What is this all about type speeches, you know?
Oh, it's completely pointless.
So the government can turn you into a